When it comes to high availability, most enterprises assume that their high availability setup will hold when needed. Their teams build it carefully, they tested it, and it works just fine. And then they moved on. But HA environments don't stay static. Infrastructure changes, new workloads arrive, configuration drift also happens, and most teams never go back to validate whether that setup that was created once will actually hold under real conditions until a real outage hits, which leads to chaos, panic, and of course, downtime. And today we have with us once again Cassius Rhue, Vice President of Customer Experience at SIOS Technology, to walk us through the simplest way to actually know if your HA setup will hold today. Cassius, first of all, it's great to have you back on the show.
Yeah, it's great to be here. It's good to hear your voice and good to see you and enjoy being with you and looking forward to diving into our topic today.
Yeah, it is really exciting to talk to you. And I think this is also a very, very important topic. It's more or less like it's not as same as that your car has an airbag or seat belt and it will work when you need it. You need to keep testing, you need to keep checking. Most organizations don't do that. They assume that their HA environment will work when they need it, but they don't regularly test it. Can you talk about why is that assumption that, hey, you know what, we have a very stable SDH setup which we tested once? Why is that assumption so risky? And what are the most common gaps that you see in HA validation today?
Great. Yeah, those are two great questions. Let me break them apart into two. First, it's a risky assumption when you're making changes, you're doing updates, even when you do the initial deployment, to think that everything's going to work fine without doing actual testing. During an actual outage or an emergency, that's not the moment that you want to discover that a backup service is misconfigured or incomplete, or that when you are doing maintenance that you forgot a step on the backup server, whereas you were able to validate things were running correctly on the production, but maybe you skipped an item. So assuming that it will work because it worked once is not a great strategy. It introduces a lot of risk to the business, a lot of risk that's unnecessary for the business. And when an emergency happens, that's when you discover those incompatibilities that leads to, as you mentioned in the intro, that leads to chaos, that leads to panic, that leads to business stakeholders wanting to understand what happened and what were the gaps. So testing and practice are critical components of business resilience planning. They show that you have a well-planned and thought-out solution when you're updating your servers, either through patch maintenance or you're doing updates to the application versions on upgrades. Doing that testing reduces the risk and helps you build muscle memory. So it's not just an exercise of will it work, but it's also an exercise of do we understand how to operate in an actual outage event, and gets you that muscle memory so that when an actual event happens, you're not going to panic. As far as the most common gaps I see, one of the worst gaps we used to see early on was the gap between customers that did nothing at all and those that did just something. And that always leads to panic when you do nothing. When you have done updates and you don't test a failover or switchover, when you've done upgrades of your application and you've not validated that they were updated correctly on both target and source. That gap used to be a really prevalent thing, and thankfully most customers realize that they have to do some validation. But I still see gaps with customers and their strategy for testing. The first gap that I notice a lot of is just the gap of not validating your actual architecture. So with the emergence of cloud and that usage growing and increasing, we see a lot of customers taking advantage of cloud resources and forgetting to validate in their architecture, did they have the right sizing for compute or network or storage? That's the first gap that I see, is just not understanding, are the systems identical in size? Are they both capable of handling the actual workload? And then once they have identified the architectural challenges and verified there are no gaps there, there's still gaps around failover or testing to make sure that client applications can connect. Some clients that we've worked with in the past simply wanted to check off, did their application or database or service start after a system failure test? But you have to take that a bit further. Having applications or services up and available on the server, the source or primary or target or backup, whichever language you use, that's a great step. But if clients cannot connect to actually use that service, then you're not really available. And then lastly, I'd say that there are customers who tend to forget to validate what happens if their application crashes. They focus their testing solely on hard server outages, but they forget that applications also need to be validated. If they crash, can the HA software successfully recover it?
Is there a simple way to test whether an HA setup really works? And if yes, what does that process looks like and how does it differ from traditional failover testing?
Yeah, great question. So I'll break it up and say that, a lot of the traditional testing has been focused solely on, can we do a failover? Can we hard crash or hard power off a node, and will it recover? Will the backup server take over operations for the applications and databases? And there are other ways to do that validation. There are simpler ways. One with the SIOS LifeKeeper solution, one of the easiest ways is what we call a switchover. And that's a manual user operation where services are gracefully stopped on your primary system and then in the correct order gracefully restarted on the backup server. The difference is in a failover scenario, you're going to hard crash a box, and that failover doesn't validate that you're able to successfully stop the application. So it doesn't go through any shutdown procedures. You're just doing crash recovery. A switchover is a much simpler test, and it validates both the shutdown operation, making sure that applications are shut down in the right order, that fencing is in place as the server transitions from its role as a primary to its role as a secondary or backup, and then also that applications and services or databases are started in the right order on the new primary system, and that fencing is now in place. And that's a much less invasive test than hard crashing a node, but it also is a more comprehensive test because it's going to hit the shutdown scenarios as well as the startup scenarios, and then also add into that for many HA solutions on the startup scenario, they're going to validate that the application is running correctly. One other thing to add to that simple test, a lot of issues can be eliminated in just validating against your own runbooks and validating that your configuration is accurate. So many of our customers create runbooks, and a very simple, easy thing to do is to validate that the assumptions and configuration details outlined in your runbook actually match the actual system. And so that can actually be done without crashing a node or taking applications offline. It's an inspection, a visual inspection first. And then, of course, we can move into these scenarios of testing a switchover or even the hard failover scenario.
Can you talk about what are the biggest challenges organizations face when testing HA environments in production, and how can they reduce risk while still building confidence in their system?
Yeah, so one of the biggest challenge, I'd say the biggest challenge I have seen organizations face when trying to test HA environments in production is securing agreement from the business stakeholders for the maintenance window required for that testing. That's also, getting business justification and building a story for the key stakeholders to sign off. We're talking about systems where even 1 hour of downtime could be as expensive as $300,000. These stakeholders are very hesitant to have those systems offline. And so the challenge becomes for those who are responsible for maintaining those systems, who are responsible for guaranteeing that the system will be available in a crisis, that failover will work, is making those stakeholders aware that doing this proactive testing While it may cost some time for the system to be offline or in maintenance mode, it also adds some resource costs that you can explain to them the savings that happen when you're not in chaos mode, when you're not scrambling to figure out what happened, why the backup server is not properly configured, or why there's an error between application versions, or why some particular client application is unable to reconnect. So articulating the value will help you overcome that challenge for businesses that are really hesitant to take a maintenance window for that. The other way so reducing that risk or hesitancy is just articulating the value of doing testing in advance, right? Making them aware that taking a proactive measure might cost one fixed amount at a particular time in the year where it's least critical to the business, but having a downtime extended by hours because you discovered the backup server is not configured properly, clients are hard coded to a particular address, or data hasn't been synced properly. You want to avoid that, and just explain to the business that in the long run, doing that testing reduces the cost and risk of chaos. Another way that I advise our customers to reduce the risk and reduce that kind of hesitancy about using HA production systems for all of your testing is to make a like-for-like copy of your production environment, right? So that's establishing a QA environment that has the same services, databases, or applications that are going to be made highly available, making sure you have test clients and that you have sufficient mock data and other supporting software in this QA environment. And then you can go through a lot of your tests and have the confidence that things are going to work because you've validated a lot of your architecture, you've validated a lot of your procedures and runbook, and that does reduce the risk. Now, I want to say that reduces the risk and the hesitancy of testing in production, but it does not eliminate it. You still need to test in your production environment. It just reduces how much testing you would have to do on a frequent basis.
Is it possible for you to share a real world example where routine HA testing uncovered a hidden issue that would have only surfaced during an actual outage and would have actually caused downtime and chaos?
Yeah, we actually have, I have two. In fact, one is very recent as earlier this week. So in the first one, we were actually working with a partner who was setting up a system for an end customer, and they engaged with us to do some testing to make sure that after their installation and updates that the system was working correctly. And our very first validation test, we discovered that one of the protected services was misconfigured. In this particular case, the service was set to what's called automatic start. So it actually would start outside of the HA solution, and when that occurs, the data that it would serve up would be stale data because it was not, a part of the HA monitoring and recovery. By detecting that early, we were able to go in, change the configuration so that it would not start outside of the HA solution's control, and make sure that it was always going to be pointing to the latest set of data. If that had been found during a real world scenario, just think of how long it may have been before the end customer discovered that they were receiving stale data. Or in some examples related to this particular environment, the client application can start in a way in which it no longer allows anyone else to access the data. And so finding that prevents an outage, it prevents an error, it prevents data integrity issues because you've detected it early, you've corrected the configuration, and then you went on to further validate that things are working properly with the HA solution. A second one related to that, to a client realizing that they had configured all of their client software. So our end customer had an HA solution in place using our SIOS Lifekeeper high availability solution. They were protecting several databases and applications. Their clients, however, were configured originally to point to the physical server IP address. And so once the applications, services, and databases failed over to the backup, those clients could not connect because they had been hard coded. Testing and validating in the customer's environment helped us find that early, make that a change and adjustment, and then get things corrected and retested in a way in which the failover and client reconnectivity became seamless. And that's something you don't want to find during an actual outage because, of course, when there's an outage, you're having to troubleshoot, you're having to do a lot more root cause analysis, you're opening tickets with multiple vendors, you're trying to coordinate understanding and what are the symptoms and signs and problems. And one thing that often gets overlooked, if the applications or databases are up and running, then you're having to go look and see, okay, what happened with clients. And that panic and chaos and that moment where you're scrambling is something that can be missed. So testing in real world scenarios helped us find that before it became an issue in an actual disaster. And then one recently, we had a client that did an upgrade of their primary system but forgot to actually do the upgrade on the backup system. And they called us in because they wanted to do some testing. And what we found is that there was a configuration file that needed to be updated on both servers. And that was something that we needed to make sure that they were able to run through. That allowed us to find the issue, update the configuration file, and also update their runbook. So now going forward, they know the procedures and steps they have to do for updates of the operating system, updates of their critical database, updates of their client application, and they know how to test it in a proper manner and where to validate that things were done correctly. And so that saves them a lot of time. Of course, if you're in an actual disaster, you're looking at, okay, well, why didn't this work? And you're starting with troubleshooting steps. And often these are the little nuances that you might miss while there are 21 executives wondering why their business is losing money by the second.
Now, let's flip this coin. Can you walk us through a scenario where an HA environment looked perfectly healthy, but the absence of routine testing led to real problems when a failover event actually happened?
That's a great question, and it's a very vivid example in my mind because of how many different organizations were involved in this particular incident and how long it took to resolve and remediate the problem, and the fact that it was a business critical system in a live production down event. So we did have a client who set up their system with our software, and they went through some what they considered to be routine maintenance. It was actually turned out to be more than routine maintenance, but for time constraint pressures or business pressures or stakeholder involved pressure, this particular client opted, first to decline services that we offer for validation and testing, and then second, they also declined to do that testing themselves to make sure during their maintenance window that that the failover would work or that the application would run on the backup. A third thing that we've kind of touched on earlier, they also did not have a test environment where they could run these updates prior to rolling them out to production. And so all of the updates were made on their production system. Things appeared to be healthy on the production node. They had an outage, a power outage in their data center. Things attempted to fail over to the backup server, and that's when they discovered that there were, during the upgrade of the primary, there were some configuration changes that were made. There were also some libraries and packages that had been updated to a newer version that did not exist on their target system or their secondary. And so when it came time to start the database failed with some errors related to those updated packages that were missing. The application, when they were able to troubleshoot the database and get it to a running and working state, the actual application failed because there were some configuration parameters that had been made on the primary and stored locally in a config file, had not been replicated or synced to the backup server. And so in a scramble, you have a team member from their organization, from the application team, trying to troubleshoot what's going on, why the application won't start. A lot of times you have in an emergency like that, you may not have the architect of the application available. And so you're dealing with an on-call engineer from the app team, an on-call engineer from the database team. You may be dealing with folks that are not as familiar with the system. And in that emergency situation, this particular customer was trying to figure all of these things out at one time. Ultimately, their resolution was to update the packages on that target system, update the configuration file, and update the database so that it would all start and run. That outage, instead of it being a simple failover, power failed in the primary data center, everything starts up seamlessly on the backup without clients noticing it. Instead, that turned into a major outage event and cost them significantly, whereas a routine test would have identified all of these issues and would have saved the business a lot of money.
Now, let's talk about one of the biggest topics these days is AI. As enterprises take on AI workloads, of course, cloud native applications and mission critical database, which is already in the wheelhouse of SIOS. Either way, how should organizations rethink HA testing as part of their broader resilience and business continuity strategy thanks to these new workloads, especially around AI?
Yeah, that's a great question. I think you hit it, in your lead into the question. Organizations have to think of HA and resiliency as a part of their strategy, right? It can't be something that you think about at the end after all of these projects and workloads have been deployed. It's something that they need to be thinking about during the requirements phase, during the architecture phase, during the design phase, as the project plans are developed, thinking about how will we recover from a disaster, how will we recover from a power fail or from an application failure, a database failure, and building that resilience, building that monitoring, building that concept for high availability into the architecture layer, leveraging it as a part of your run books and making sure that for whatever strategy you have deployed, that you're making sure that you test it. And then, one of the things that AI tools provide, they will give you a lot of capabilities for developing these designs, for validating these architectures, for even creating some of these run books based on your requirements, based on what workloads you have involved. And then, of course, as we've been talking about over and over again, is making sure that you build routine testing into that strategy.
Let's assume that there are teams who are just starting to build a regular HA testing practice. Where should they start and what does a realistic cadence look like for them?
Yeah, that's a good question. If you're just starting by building out an HA test infrastructure, right? So let's assume that you've made sure you're doing a like-for-like copy of production. What you want to look at is what we tend to see with a lot of customers and recommend is what is your business cadence, right? So there are a lot of organizations that are doing monthly patching. And so you want to make sure you're matching your HA testing to the cadence of the business. If you're doing patching every 3 weeks, then you want to make sure your test environment is set up and that your plan is, your project plans include time for you to test and validate in that QA environment before you start doing the rollout on your production system. There are also organizations that in addition to their monthly patching or update strategy, they're also doing like a quarterly or biannual disaster recovery exercise. And so I would say start with looking at your business requirements. How often do you need to update your production nodes? How often do you need to do disaster recovery scenarios, either to satisfy a business requirement, a regulatory requirement, or a certification requirement for your particular industry? And use that as the groundwork or framework for how often you do the testing.
Are there specific tooling or automation approach that makes continuous HA validation more practical without burdening already stretched IT teams? And how does SIOS help there?
That is a really good question, and great thing for teams that are thinking about testing or trying to make that burden lighter. Automation can play a huge role in reducing the friction, reducing the cost, and increasing the frequency of doing that testing. A lot of tools exist out there, so I won't name specific ones, but what you want to look for is a framework that allows you to integrate key test functionality for your applications or services in your HA environment. We talked about tests that do hard failures and then making sure that applications and services restart. So you want to look for automation tools that allow you to have a framework that can simulate node failures, that can activate the HA solution functionality. A lot of HA solutions like SIOS, SIOS has an extensive command line interface that you can use for automating either through scripting or through automated tools that simply interface with a CLI or API. And that allows you to say which particular commands are most important for your test environment. If you're, for example, doing patch maintenance, you can automate everything from deploying the patches, restarting the application, testing the failover, testing a failback, testing a switchover, switchback. There are lots of commands in each operating system, whether it's Linux, Windows, that allow you to do things to crash application services or stop databases, and then you can use those automated HA tools or HA CLIs to validate that things recover properly.
Cassius, thank you so much. This has been a great conversation. Thank you for breaking this down so clearly and giving our viewers something they can actually act on. And I would encourage everybody who is watching it to check out SIOS Technology to learn more about how they can help their organizations protect mission critical systems. Cassius, once again, thank you for joining us, and I look forward to chat with you again. Thank you.
Thank you so much for having me, and look forward to our next conversation.